Hi everyone and welcome back to the first module Windows Internet Overview in the Evasion Lab course by Art Security. Now we will see the difference between different Windows versions a process. By the help of Virtualis projects, we will take a look the difference between a process fields offsets between Windows 11 and Windows 8. So a unique process ID offset in Windows 11 is 1D0, but in Windows 8 its offset is 2E0. So they are quite different. And active process links offset is 1D8 in Windows 11, and in Windows 8 its offset is 2E8. Let's take another look at the token in Windows 11 and in Windows 8. The token in Windows 11, its offset is 248, and in Windows 8 is 348. So they are very different, and using the offset of Windows 8 in Windows 11 a process will cause a kernel crash, or known as blue screen of death. So pay attention of using the correct offset for different Windows version. So let's launch CMD in this machine and try to use Windows kernel debugger in order to monitor its process. Now let's stop the kernel of that machine and monitor the process of cmd.exe. We can see that this is the address of the process of cmd.exe. This is the PID and this is the parent's PID in hexadecimal, and we can check that is actually 4472, which is the PID of the previous CMD. So now let's look at the process fields of that CMD by typing this command. And we can see different process fields, and we are interested in a couple of them, like the unique process ID, which refers to the PID of cmd.exe, active process links, which is a field that contains links to other processes, allowing enumeration of all active processes. You can see the protection. Its offset is 87A, the token as well. Its offset is 4B8, and the image file name as well, which representing cmd.exe. Now let's try to hide that cmd.exe from the process, from the process explorer entry, and to do so, let's list again the offset of active process links, which is 448. Remember that, and it's of type list entry. So that structure contains two fields, the flink and plink, at offset 8. They are both of type list entry as well. So let's get the process of cmd.exe the address of process cmd.exe is that, and get the flink and plink of the active process links of cmd.exe. So to do so, we type this command dtnt list entry and the active process links address, which is the process plus the offset of active process links 0x448, and this is the address of active process links of cmd-exe, and this is the address of active process links of the next process, and this is the address of active process links of the previous address. F-link is pointing to active process links of the next address, and blink pointing to active process links of the previous address. And this is the F-link of the active process links of the previous address. This is the blink of the active process links of the previous address. This is the F-link of the active process links of the next address, and this is the blink of the active process links of the next address. So to hide cmd-exe from this linked list, we have to override the previous active process links F-link with the next active process links. So let's do it. The previous active process links F-link is this at offset 0, which is this exactly. Hide it, override it with the next active process links, which is this. All right, and hide and override the next active process links blink with the previous active process links. The next active process link blink, which is this plus 0x8, override it with the previous active process links, which is this. Next, we will override the current active process link F-link with null, and current active process links blink with null as well. So the current process active process links is this, the F-link is this, override this with 0, and the current process active process links blink is this, override this with 0 as well, and click on G to continue the execution of the target kernel. Now let's authenticate to the target machine and see if the process is successfully hidden. Right, cool. So we can see that cmd-exe is not shown in the process explorer entry, but it's still running, and we can type sub commands. Good. So the process is successfully hidden. Now we will take a look at the token and try to do some privilege escalation for a different process. Let's kill that and launch another process. It's shown in this entry. Its PID is 5840, and try to steal the token of system and give it and change the CMD's token with the system's token. To do so, let's get the eProcess of system and the eProcess of cmd.exe as well. Now let's get the DT. Let's get the offset of the token from the eProcess by typing this command. You can see the offset of token is 4B8, and use that command to get the token of system, the token value of the system. Fast ref and the eProcess of system plus the offset of token 0x4b8. So this is the token value of system. Now we will change the token of CMD with the system token. To do so, we type the CMD process, change the CMD process, and this is to access B8 to access the token, and change the token of CMD with the token of system. Now let's inspect the token of system, the token value of system, by changing this with the eProcess of CMD. And we can see that the value, the token value of CMD is similar to the token of system. So if we continue, press G and get back to the MKTG machine, the target machine, and authenticate. We can see that we are successfully into authority system. We successfully did the privilege escalation. Now let's do token and EDR downgrade by downgrading the MSMPENG. Let's monitor its token, and we can see it's under the user into authority system, and those are the privilege. Let's do the similar thing by changing the token of MSMPENG with the token of Explorer. To do so, let's get the eProcess of Explorer. And get the eProcess of MSMPENG.exe. And get the token of Explorer. So this is the token value of Explorer.exe, and change the MSMPENG token by specifying the eProcess plus the offset of token to get the token, and change its value with the value of Explorer, which is this, and press G. And if we get back to this target machine and monitor the user dot MSMPENG is running now with is sorry, you can see the privileges of MSMPENG are changed to Explorer. So Explorer privileges, we have just 2. Maybe we have to rerun the Explorer.exe so the field of the user get changed or updated. We type MSMPENG and check the user. We can see that the user is successfully changed to MKTG user 1, and the privileges are the privilege of CMD.exe. If we check Explorer.exe, you can see they have the same properties in the everything related to privilege. User, the seed, and the groups, and the privileges as well. Now, let's check LSS.exe, and we can see it's protected with PS protected signer LSA Lite. And if we try to use Task Manager to dump its memory, this protection will prevent us from dumping its memory. You can see the operation could not be completed, access is denied. Now let's try to remove this protection from LSS using WinDBG. To do so, let's get the eProcess of LSS by typing this command. This is the eProcess address of LSS, and gets the offset of protection by typing this command and changing the LSS eProcess. So the protection offset is at this offset, and we can see it's protected with LSA protection. Its value is 0x41, and to change that we have to type this command, specify the protection address plus the offset of the protection 087A, and specify the protection level value, which is 00 instead of 41. And if we type the value of the protection again, we can see it's removed. If we click G to make sure that the target kernel is executing, enter the credentials, and relaunch Process Explorer so the fields get updated. Let's leave that for later. Run it with administrative privilege and check LSS.exe. Now it has no protection, and we can dump the LSS process. Please wait, and LSS is dumped now successfully.